as supplementary angles. So, but this way you have an example of complementary angles. So at the very top of page 274, okay, I would encourage you to write down complementary there, angles, okay? At the very top, what is sum is equal to 90 degrees, okay? So you're gonna want to focus in on anything that looks like it's a 90 and that is being cut, okay? So at the very top, you should put this down, complementary. Just focus this in a bit. Hey, you're all here, guys, on a Friday. Way to go. And you're awake. That's also important. The captain of a boat sees 2 points of a land. Point C is 1.8 kilometers east, right? So this is the boat, the captain, 1.8 kilometers east of the boat, and point A is at a bearing of 12 degrees. You're like, what is bearing? If you know anything about navigation, when you're in the, on the sea, you don't have streets, right? There's just water everywhere. Same if you're a pilot, you can just fly over everything. So bearing, like a 0 degree bearing would be straight north. If you're headed 0 degrees at a bearing of 0 degrees, you're heading straight north. If it's 12 degrees, it means you're obviously you're starting north, but you're deviating 12 degrees towards east in this case, and that's where you're headed, right? And so you can tell that it's 360 degrees all around the bearings, right? If you're headed at a bearing of 180, you would be heading straight south, right? Because there'd be 90 and another 90 you're heading. So this is just a crash course on bearing. You don't really have to remember that. But some of you probably know what I'm talking about, right? Even if you're if you're hiking through a forest, you probably are going to use compass directions as well, right? There you go. Okay, so we know these two sides, check, check. Right now, no angles inside the triangle, correct? Okay, is there a way to perhaps get an angle in there given that this 12 is just lurking there? And the answer is yes. I will just make this little sliver pink, right? Like that's what you know, that is the 12-degree angle. It's way up here. It doesn't matter where, right? But it's 12 degrees right there. And so we can figure out the green part of that angle, right? This inside here. And I think you can already guess where this is going. It's not a straight line along the bottom, right? It's actually there's a 90 here in this corner between the east line. This is east here, right down east. And this is north, right? And so we're deviating. You would all have to agree that between east and north, right? Those lines, they meet at a 90, correct? Okay, so we have a 90 degree between those two lines. And so to get the green part, we just go 90 minus 12. And that is 78 degrees. I will highlight that green. Okay. So I will say that that is what goes in here, 78 degrees. And now you have an angle inside the triangle. So right now it's basically what we've been doing all along, right? So I'm basically preparing you for the AC as well. So you have a pair, okay? This is your pair. So you have your sine law, right? You have a pair, we use sine law. And I will do a cosine law in a bit. Sine law. Okay. So let's go ahead and solve that. So sine of 78 degrees, lots of room down here, over 2.5 kilometers is equal to sine of What are they asking for? How far is the boat from point A? So they're actually asking for this side, correct? Let's put an X right here. This is what they're asking for. This is also known as side AB, right? Length of side AB. Can we find that just off the top? No, we're in trouble because we don't know C here, right? So what can we do? We can find this angle in the meantime. Okay, so do that. Sine A over 1.8, right, kilometers. I will just put a note here. Note, can't solve for side X yet. Okay? Can't do that yet. You need to do something else. But, right, we knew this side, so that tells us that we can find the angle across from it. So sine of A, watch this. Your notation is important here. You cross multiply these two. I choose to take the number first. Sine of 78, right? Multiply them, divide. Did you know that just by showing your work, setting it up, picking the right law, you could score 2 out of 3 without even giving me the final answer? So if you're so focused on getting that final answer, right, show me work, and then you can score quite a few marks because it tells me you understand what's happening, right? So this gives you, you go ahead and type that in as well. You never know, right? You might learn something new. 0.704 continued. Leave it on your calculator. I don't know, I like using all decimals if possible, right? You're as accurate as can be. Okay. So my next line is, actually, you can just say A, right? Hey, now I can find that. I'm going to use sine inverse of 0.704 dot dot dot. And I'm going to perform that operation. You know the joke about the doctor? He's like, so many patients lining up outside. It's like, which patients should I see first? Yeah, he asks the nurse, and she just says, just follow the order of operations. Dun, 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 right? 44.77. You're a tough crowd. That's okay. 44.77. We're not done yet. We're not done yet. We need, but we have more information, right? Let's go back to our diagram. We just found this one. You know what? It doesn't hurt saying, hey, I know this now. Right? I know that angle. I just found it. I'm going to place it in there. Now that you have that angle, you can find C, correct? Okay, let's do that. I will box this all in to show, hey, this is all one step here. Angle C is 180 minus 78, which is that green angle I found, minus the one I just determined. So 180 minus 78 minus 44.77, 57.23. It's not the final answer, but it's definitely an important step. I will box that in too, because that happened next, right? Now I can solve for side X, right? And I would encourage you, we're talking the same triangle, so just use that pair that you had at the very beginning, right? This one, I'll be using it again. And now what? You got to be careful. Sine of 57.23. Why don't we write that in as well? This angle here is 57.23. Way up there, right? So that is across the side that I'm interested in. This is a lot of work, yeah. I will usually guide you through it on a test. I'll say, A, find this. B, find that. But there's still instances where you have to know what to do, right? Like what step needs to be performed. We're going to call this X. This is finding a side, not an angle. So cross multiply, right? You cross multiply here, and you divide by what is left. Sorry, can't see that, can you? There. That's why I left so much room, right? 0.5 times sine of 57.23 divided by sine of 78. That's 2.15. 2.15 meters, right? Yeah, kilometers, sorry, kilometers. That is the final answer. That's what we've been after all along. And I will box this in here because that was my last calculation. We're good? Okay. You know, I heard something very funny on the radio, how to save money. This one guy texted into the radio saying that he always gasses up to like so that it ends in like, what did he say, 2 cents, and then he pays cash. So he'll gas up 10.02 and go inside and pay $10 because they round down, right? So he keeps on doing that to save 2 cents every time. And I'm like, oh my goodness. Penny pinching. It works. It works. You just have to show face, right? But you don't save 2 cents a liter. You just, I guess you can gas up a liter at a time, and I don't know. Anyways, interesting. Another one, guys. I'm taking you all the way to page 282. All the way to 282. It says it up there, working with supplementary angles, but this is cosine. This will be a cosine law example. I want you to have not just sine, sine, sine. I want you to have a cosine law. So this is 282. I'm not going to do every single example in this booklet. Once I have done enough, then we're just going to the workbook, right? And I'm going to ask you to do some questions there. You know why I don't like this booklet in particular? Because they split it up into everything sine law, everything cosine law. I don't like that. I want it to be mixed up, right? Otherwise, you don't know how to distinguish, how to determine. Okay, so here we go. A little bit of a twist here as well. So you learned about bearings. Now you're going to learn about speed and time. Okay, a ship travels south from the port. So this is the port, right? It travels south straight down for 2 hours at 35 kilometers an hour. If you travel for 2 hours and you go 35 kilometers per hour, how far did you travel? 70, right? 2 times 35, there we go, 70 kilometers. So instead of giving you the distance, they kind of put a little twist on that, right? So you know that this distance is technically 70 kilometers. Okay, so this all you need to do is multiply your time. It could have been 1.5 hours. You still do the same thing, 1.5 times the speed you travel. It then changes course. Watch this. It changes course, and travels 20 degrees west of south. So that's this angle right here. Okay? That angle right there is what that is representing. Do I spend the time to explain that to you? I don't know how much value it really gives to this unit, but I think for life it doesn't hurt. So real quick here, when you see degrees west of south, it's actually saying that, like, if this is your starting point and this is the south line, 20 degrees west of south, that means that you have to, like, you start on the south line and you turn west 20 degrees, and that's the actual trajectory you're traveling on, right? If it said, let's do this, 40 degrees east of north, like if you were to, let's say your life depended on it, you have to run for your life. If somebody says, hey, just go 40 degrees east of north, I hope you'd be able to figure it out. East of north. So that means that you need to kind of imagine the north line, and you're turning 40 degrees east. Which way is east? This way, right? So that is this direction that you should be traveling in. Okay, other than that, you won't have to worry about it. I just wanted you to know. Have you ever seen this stuff? Yeah? Where would you have heard it? I'm just curious. What's that? Cadets. Okay, got it. Makes sense. Yeah. Yeah. You need to, in the world where there are no streets, that's how you travel, right? On water, in the forest, this is kind of where I'm heading, right? It can save your life if you know where you're going, right? Okay, and then you turn here. This is the turn, right turn down, okay, turn. And then you travel 3 hours at the same speed. So 3 hours times 35 kilometers per hour. So what is that? 3 times 30 is 90. 3 times 5 is 15. So that's 105 kilometers that you will have traveled if you travel the same speed. So this line, this side on this triangle is 105 kilometers. Okay, let's circle this. This is just like an aside. This is how we kind of do our math to come up with the sides. And we have a problem, right? Do we have it? We need an angle inside the triangle. We kind of need that. The only exception would have been if you knew all three sides. That'd be a different story, right? Side, side, side. You can use cosine law for that, but you don't, right? So we're going to find that, right? We can do it. You notice that this is a straight line, right? So that means that this angle right here on the inside would be 160 degrees, right? You can do that without even flinching. Okay. So now you have side, angle, side, right? Yeah. Okay, I'm just making sure you're paying attention. So that means I need to use cosine law. Okay, so you should have them on your formula sheet, or you can have it on your study sheet. But I know that to find this side, let's call this M, just to change it up a little bit, right? To find that side, you need to just take the other two sides, square and add, right? Then you're going to go minus 2 times the first one, times the second one, times cosine of 160. Do you remember what I talked about this, right? What's cosine of an obtuse angle? Negative. It's negative, right? So you got to be careful if you're not typing this in one shot. You got to watch out. because this negative and that negative will turn this whole thing into a positive. So it's really add these two added and this whole thing added to it, right? But I don't need to worry about it because I typed this in one shot. Watch. 105 squared plus 70 squared minus 2 times 105 times 70 times cosine of 160. And that's what it is, right? 29, 738, 48153. It doesn't hurt writing the whole thing down. And so we take the square root of that, that's 172.45, and we are talking kilometers. So the ship, after traveling 2 hours this way and 3 hours that way, that's a 5-hour round total trip. We now know that the direct distance from the port to the final destination is 172.45 kilometers. Okay, so here you have supplementary cosine law example. So you kind of have to fish for it, right? You got to go through your booklets. Like let's see supplementary again. I'm going to give you a test checklist later on, so you need to watch out for supplementary. Just kind of know what to expect. Okay. All right. How much time do we have here? Okay, we'll do the AC now. The AC has none of this stuff. Okay. Once we are done with the AC, because it's just maybe I'll give you a little bit of time. I'll give you a couple minutes to review. Do you remember that Pika question? The width of the river, do you remember that? Maybe just spend some time looking at that, because that may or may not be on the AC that you're about to get. So just peek at that, review it. There's also a tree one, the height of the tree.